but yeah, that is how it is going to be. So in the network layer, you see it says that this is a logical addressing. So this is an IP addressing. That means you are doing two things. One is you are understanding your source IP, that is your SIP, and then there is a destination IP, that is your DIP. And remember, in the previous part you got your segment. So in the segment there was TCP UDP header, and then it was your data. So now if all of this information is broken down, it becomes a packet. So it receives segments and then converts it to packet. The network layer does this work. So if I just go back, so the application layer send data to presentation layer send the data to session layer, the session layer send the data to transport layer, and transport layer added whether it is a TCP or UDP and broke it down into segments. Now this segment is added with source IP, destination IP, and now it is called as a packet. Now each packet size is from 64 to 1500. And okay, when I did, okay, if I also show you something like this, I'll open my command prompt. See, if I just say ping google.com, okay, this is an IPv6 address, but what I want you to see over here is, you see it is saying 32 bytes of data. So this is the size of my hello packet that I'm sending to google.com. Okay, so instead of an IPv6 address, I'll just show you this 127.0.0.1. Yeah, so see here it is much more clear because we are able to understand this as of now. So let's say my packet size was 32 bytes. I sent it to this IP address and I was able to receive back my packet. So see here it says packet, here is the size. That is what we are trying to say here. Okay, and let's talk about this. We'll come back to the protocols as and when required, but yeah. So the transport layer sends it to packet. Now the packet is sent to data link layer. So in this data link layer, it would add some other information. So see, this was your packet that was having source IP, destination IP, TCP, UDP data. But now you are adding the source MAC address and destination MAC address. So what is a MAC address? MAC address means for every device, you have a unique network interface card. So these cards are having certain unique serial numbers is what you can just try to understand for a simple reason. MAC address is your media access control card, whether that is a wired or wireless connection. You can also say it as a network interface card. For that, there is a unique ID that has been given, and that is called as a MAC address. So source MAC and destination MAC will make sure that your laptop has been identified. So which laptop the data was sent and which laptop the data was received. So data link layer adds such information and converts the packets into frames. So until now it was called as a packet. So that after talking about data link, it would become a frame. Okay, let me do a control set here, and you can see okay, like I did mention, MAC address is a 48-bit address. Now this is basically going to store the individual laptop's ID. That means I did show you the example where personal one computer 1 was communicating to personal computer 2. So how does it know that via the internet personal computer wants to send from machine 1 to machine 2? That is possible via MAC address and IP address. Both of them work in combination. Okay, and your MAC address is always stored in a table that is called as ARP table, and that is managed by a protocol that is called as ARP protocol, that is address resolution protocol. So all these ARP data is stored in a router or a switch. So we will be coming and talking about these topics to and fro. This will be in like forward and reverse direction multiple times because we will be missing, you know, a lot of stuff. Like let's say we'll be talking about different protocols, routers and stuff, right? So I said HTTP protocol, SMTP protocol. So what they are, I'll once again explain them. But for now, just try to understand the layers. Once this is clear, we'll talk about protocols. Then we'll say how the communication takes place. We'll talk about protocols, and then it will be much more clearer to you, right? So the packet was converted to frame, and then finally in the physical layer, it will be converted into zeros and ones. Now let's say whether it is sending or receiving. Let's say the frame was sent to physical layer. So here it got converted into zeros or ones, whatever happened, and then the communication took place. Once that communication took place, again, if I show you this, so data was sent in the transport layer. It becomes a segment, then it becomes a packet. The packet is converted to frame. The frame is converted into zeros and ones. So this is while sending. Now once it reaches the end device, then again here you have received zeros and ones, right? That zeros or ones will be converted to packet. Then whatever extra information that this data link layer added, it will remove that and it will make it as a segment. So again, in segmentation layer also, whatever extra information was added, it will be removed, processed, and then it becomes data. Now this data is uh, first made sure that the session was established to make sure that it is going to the right person. Then uh, you will go ahead, you will convert that into user readable format by any encryption, decryption will take place, or compression, decompression, whatever. And then finally you will be able to view it on your application. That is on your any kind of application, whether it is Google Chrome, your WhatsApp, or anything. Okay, so this is how basically the communications takes place.